Thank you, everybody. Greetings from Nairobi. So last week, we had Georgina Emba from Israel, Senegal, presenting her research on maize using molecular tools, including mid-density genotyping in Senegalese breeding programs. So today, we will introduce sweet potato research from SIP with the support of Dr. David Decoyer from the Agriculture and Agri-Food Canada. So Dr. David is a renowned potato breeder and geneticist, and he's the leader of the AFSC's National Potato Breeding Program. So his work is focused on potato breeding and genomics, and some key aspects of his work include the creation of elite potato clones with desirable attributes such as storability and quality for both processing and fresh markets. His research contributed significantly to sustainable potato production and the potato industry success, and is key in addressing challenges posed by climate change and ensuring resilient potato varieties for the future. Thank you very much, Dr. David, for accepting this request. We are very, very honored to have you here, and thank you for your time, and I will let you to add more to my words of your work and to present both to us Godwill and Ruben from SIP. Thank you very much.
Thank you, Anna. Thank you for the opportunity to present to this seminar series. And it's great to be connected with some former colleagues in IITA and collaborators with SIP. Today, I'm just going to give a brief overview of my research program before I introduce today's speakers. So I work with the Agriculture and Agri-Food Canada. I'm based in Fredericton, New Brunswick. So as you know, potato breeding is a continuum from very basic work all the way through to cultivar development and industry, and we work all along the continuum. And the important aspects I'll try to emphasize today is the integration of molecular genetics and genomics and other bioinformatics type research into our breeding pipeline. Using new technology and tools, we've updated significantly our breeding pipeline, starting from selections of parents through hybridization, generation of botanical seed, growing the seedlings in the greenhouse, and then carrying on the clonal multiplication and testing up through 6 years. We have introduced new trial experimental designs, incorporated a better data management system, and are addressing some of the needs of our product profiles by incorporating marker-assisted selection and genomic selection in our breeding system. As you know, Canada is a big country, so we have research that's ongoing across the country from coast to coast, and with 2 major breeding sites in New Brunswick and in Alberta. Recently, we've gone through some restructuring and developing a new strategic plan for science. This involves mission-driven science that is directed towards 4 mission areas, mitigating and adapting to climate change, increasing resilience to agro-ecosystems, advancing the circular economy, and accelerating digital transformation. So the work that we do in mitigating and adapting to climate change includes improved stress tolerance and adaptation, and developing sustainable food production systems for the northern Canada. As you know, because there's lots of diverse locations, it's important to have testing across the country and to compare performance under different conditions. And this is an important element of our breeding program. It also allows us to identify selections to advance in the product development cycle and provides industry members an opportunity to participate in selection decisions. So the second mission is increasing the resilience of agro-ecosystems. We do this by leveraging genetic resources and expanding our resistance to biotic and abiotic stress. And one example is potato wart resistance testing. It's a quarantine pest, and we've been successfully using molecular markers to select for resistance to this pest and to adapt to the trade barriers that have resulted from the finding of this pest in Canada. So we collect a lot of disease data, and most of these diseases we use markers to screen for these resistances. The third mission is advancing the circular economy. So we have diverse production systems with multiple outputs, and we're directing our research towards emerging food and bioproduct opportunities, as well as improved product recovery, such as fewer defects, longer storage, etc. And the fourth mission, which is more directly related to our work in genomics and bioinformatics, is accelerating the digital transformation of the agriculture sector. So as you know, data is critical along the continuum of breeding, and we have used this to optimize our operations and create new opportunities. For some reason, this has gone backwards. Could be switched to. So for the breeding data management, we use BreedBase as a pipeline for tools, including the pheno apps like Breed Fieldbook and other BRAPI applications.
David, apologies for interrupting.
Yeah.
It's still on presentation, not presentation mode, please.
Yeah, I'm trying to see how to switch that. Oh, geez, I can't seem to switch it to the other one.
Maybe you can start to share and reshare again. Yeah, thank you.
Apologize. I don't know why this happened. This happened before.
So David, I think this happened in our previous. Go to display settings. Yeah, exactly.
Yeah, it's up there, but I can't reach it. So for some reason.
Okay.
So, no problem.
Sorry.
Yeah, please proceed. No problem.
Yeah, I'm almost to the end, and I'll just continue on here. Sorry for this challenges. So mentioned, so we're using different tools for faster reporting and objective data collection, including image analysis and an optical grader, and doing different types of improved phenotyping to collect a massive amount of data that are helping with our breeding systems. And finally, this is my last slide, just in the process of doing our research, we use different potato genotyping platforms, including low density CAS assays in-house and through the excellence in breeding, and also mid-density DART tag, which we use for quality control and marker assisted selection, and starting to use genomic selection in the earlier generations. And then finally, the high density Neogen SNP array, which is a 30,000K SNP, as well as other platforms we're using for genome-wide association analysis, genomic selections, and optimized parental and mate allocation. So I have some links here that have a lot of tools that are useful for polyploid genetics. So with that, I have my contact information here if you have any questions, but I will switch to introducing to our esteemed speakers today. Today we have two speakers from Africa. So the first speaker is Dr. Reuben Sali, is a sweet potato breeder from the International Potato Center SIP in Uganda. And he's an experienced sweet potato breeder and is working with the sweet potato genomics group in team, which has involved multiple institutions across the country. And he'll talk about some of his work that's related to this activity. And also Godwill Akundi is based in Mozambique and also working for the International Potato Center, and will talk about his work on potato genotyping. Thank you very much for the opportunity to introduce the speakers, and I look forward to the rest of the presentation. Stop share.
Ruben, are you able to share your screen, please? Thank you.
Okay. Thank you very much.
Still not in presentation mode. Yes, thank you.
Is that fine now? Okay. Thank you very much for the opportunity to share with you the work we're doing, how the low and mid-density panels are helping us in sweet potato breeding. Right away, invite my colleague Godwill Makunde to get us started. Godwill, you can take it on from there.
Okay, thank you very much. Thank you, Anna, for providing us this wonderful opportunity to talk about sweet potato. Thank you, David. Thank you, Ruben, for introducing us. So good afternoon or morning, depending wherever you are. My name is Godwill, and I will take you through the introduction sections of the presentation. So like the title is saying, we are talking about low and mid-density panels for sweet potato, their practical implications for breeding in Africa. And I'm presenting first on behalf of Ruben, myself, and the whole breeding team in SIP. Can you move the slide? I cannot move, Ruben. So as a way of introduction, I would just like to remind all of you the importance of sweet potato as a food and nutritional security crop with the ability to reduce hunger and malnutrition in our populations. However, despite its importance, the production is quite low. And to your left, there is a map of Africa, which indicates production in various countries. And critically, it's below 6 tons per hectare. And there are many reasons which are attributed to this low production in Africa. And the first one is related to climate change and the related weather patterns, mainly the drought, low rainfall, which is variable. It's reducing our yield. And the second reason is because of biotic stresses, which are always affecting our sweet potato in the field. And this has to do with the virus pressure and also weevil, which is the ability to reduce even the quality of the crop. And then the third point, which reduces the production, is because of extreme use of land races by farmers, and this is related to varietal use and our inability or the inability of the seed systems to promote improved varieties. However, in SIP, we are ready to tackle these challenges, and we have got a well-coordinated international breeding efforts involving multiple partners. And for a long time, we have thrived in a community of practices with the different partners across Africa. And now we have evolved to move to CGIAR breeding networks, especially the RTB crops. So just to give you how the breeding programs are arranged in SIP, the breeding efforts are championed at 3 sub-regional platforms, 2 in Africa, and in Africa, which serves for the Eastern Central Africa, is based in Uganda. Southern Africa, the platform is based in Mozambique. Then we have our HQ in Peru, who are specifically supporting us in terms of pre-breeding, development of methods and materials. And in all our work, we are linked with the National Participatory Varietal Development as we move towards variety advancement and the release of varieties. Ruben, please, next slide. So, why have we moved to low and medium density genotyping platforms? I think they are very helpful for us in terms of marker-assisted breeding. We are also taking that direction. And in general, they are cost efficiency. So for CASP markers, what we have done, we use them in QA, QC, and the major reason there is as we are doing our clone advancement and germplasm exchange and flow with the national partners, we want to make sure that some of the errors which are associated with mislabeling along the breeding cycle are eliminated before germplasm exchange or any advancement happens. And for the middle density genotyping platforms, we are exploiting them in our breeding schemes. For example, in the process exploiting breeding scheme, the separation of gene pools, these markers are quite useful. And also in genomic selection, as well as the selection of multiple traits. And in Africa, for example, the germplasm exchange to our right, you can see the reach CP has reached from its 2 platforms, and also some spillover countries in assistance always with the different partners, the national partners and the universities. Next slide. So this slide is talking about the low density markers, which we have used. We have also used the CASP markers to genotype some of our parents and also training populations, mainly from 3 different countries, Uganda, Tanzania, and Mozambique. And we are also involved in national partners. For example, in Uganda, NACRI has also contributed to this work. And Tanzania, this is work from the national program. And in general, we have used 64 markers. We have calculated the genetic distances. And most of this work has already been reported during the first presentation in this seminar. And this was done by Mokhtar and Guy. And they were specifically talking about the CASP markers for QC in potato and sweet potato. But one of their conclusions for the CASP markers, they said that for sweet potato, these markers demonstrate significant discriminatory ability, making them more suitable for identity analysis, especially for sweet potato, even potato. Next slide.
Thank you, Godul. I think I will take it on from here. Next, I would like to share with you some of the genotyping projects we have undertaken using the mid-density genotyping panel. For sweet potato, we have one panel that was developed by the Breeding Insights at Cornell University. It includes 3,120 markers, marker loci, and it was developed from 48 sweet potato clones, most of which were from North America. And some of the projects we've undertaken include comparing clones from the 3 SIP breeding platforms. For instance, we sent samples through Intertech of 282 sweet potato clones that included mainly some parents and materials at the preliminary youth trial from Uganda. Then for Mozambique, we sent 846 samples, including parents, the high iron population, and some landraces. And then we sent materials from Peru, which included 376 samples. There's a population that has been developed through reciprocal recurrent selection. We call it the jewel population. And then also there's a palo population. And then we have some purple flesh clones, and a number of advanced varieties were sent for genotyping using that mid-density panel. When we received the results, we were able to make hexaploid dosage calling, and with that, we were able to also look at the quality of some of the results that came through, and these were filtered based on the number of total counts, the core rate, and the minor allele frequencies. There was a very big variation amongst the samples that was sent there, that was sent for genotyping. We thought some of it would have been due to the way the leaf samples were collected. The sampling for the Mozambique and Uganda, we punched the leaf discs before really drying them, while the team at Peru first dried the leaves and then they punched the leaf discs. But then also, we also think that during the process of genotyping, the extra DNA treatment step that was used for the samples from Peru would have improved the number of optimal alleles. So by and large, at least a total of 988 markers were common and were used for much of the analysis in this study. To obtain the dendrograms, the Euclidean distances and the unweighted pair group method clustering was used, and we were able to confirm the clusters by breeding platform. You can see Peru in pink, Uganda in yellow, and then Mozambique in green. Although when you zoom in, you still see traces of materials from either Mozambique into Uganda or Uganda into Peru. But this also confirms the germplasm exchange that we keep doing amongst our platforms. When you look at the Mozambique, the landraces and the high iron population and the parents clearly separated, clustered together as well. So this was very encouraging that although the panel was developed with materials from North America, it still could readily be able to distinguish between populations. materials. A similar case would be seen for Peru. You can see the purple flesh clones clustering together. The populations of Palo also clustering together, and the population jewel also clustering together. So this gave us a lot of promise for us to be able to use this mid-density panel. Another genotyping project that we have conducted with the mid-density panel involved confirming the pedigree of some of the crosses we make. When we're making, we have what we're calling isolated biparental crosses. Here, you simply plant two parents with a good together, with good isolation from other sweet potato production activities, and that way you're able to generate diversity for evaluation, most especially for our product development. So we do this with our elite crosses in both Uganda and Mozambique. And what we really wanted to do is to confirm whether there's no serious mix-up, there's no, that the pedigree we are assuming is still the pedigree that the actual parents have. So in this project, we went about it almost the same way, using filters for minor allele frequencies, and more than 2,000 markers were able to return this time around. And with the clustering still, you can see that families were clustering together. When you look at the zoom in the upper corner, you're seeing the family of Nasport 7 and Wagabolike together, and then also Wagabolike, when it's alone, it's also clustering independently. So this similar pattern was seen across the entire dendrogram, and we thought this was also another good indicator that this panel is really useful for us, most especially for the pedigree confirmation. Then another project we've used this mid-density panel is the SIP Uganda training population. We constituted a training population of 1,138 progenies from 20 intragene pool crosses and another 20 intragene pool crosses. So there are 40 parents, but each set of 20 is coming from one gene pool. And we were able to evaluate this across 3 locations. And one of the things that is coming through is that we are having, when we used the panel to compute the genetic relationship matrices, most of the traits had marked improvement in the heritabilities. This also boosts, because we're using GBLAPS as our proxy for breeding values, this also enabled us be able to understand that that it's much, we get better selections when we use when we add that genomic relationship matrix, still using this panel. And the PCA just shows the different gene pools and the constitution of the families that made the genomic selection training population. Going forward, we realized that the DAT tag markers for sweet potato are suited to analyze genetic diversity from the few projects that we've conducted. But then also they're helping us be able to select parents for our crossing. Then we recently had a comparison of our projects with some of the projects that have been conducted with this panel by Breeding Insights and then other sweet potato working groups. And a lot of monomorphic markers could be seen across projects. And right now, what we're doing is to try and work with Breeding Insights to be able to update this panel so that it can be able to work across sweet potato populations. Also, we noticed that the protocols need to be revised so that the results from one project are not superior to those of another project in terms of, so they need to be revised and homogenized so that we have better quality every time the panel is utilized. We noticed that from our comparison of the dot tag markers with the mid-density markers, we noticed that the dot tag markers were giving us more power, but we also know that it is it will be quite more costly. So we are wondering if we can customize them to maybe like 150 markers, smaller subset, which can be used for our QA/QC in going forward. Then in some of the projects, we were able to work with national partners, most notably TARI and NAPRI. But then we believe that with more capacity building, we can be able to work with many more partners in the network. So it's also an area that we think would be able to improve the utilization of these markers. With that, I would say thank you very much for your attention.
Thank you very much, Godwill. Thank you very much, Ruben, for the excellent presentation. So we are open now for questions. Please unmute yourself if you have any question, and you can ask directly to the presenters. I think I can start with one question for Ruben. Ruben, can you explain a little bit better the intragene crosses, if I understand well, please? Ruben, you are muted.
Oh, sorry. Come again, intra-gene pool crosses?
Yes, in one of your slides, you talk about the intragene crosses. Could you explain just very briefly? Or did I understand?
Okay. Allow me use okay. We are using the hybrid breeding, or we're trying to exploit heterosis in sweet potato breeding. We have conducted with a smaller subset of parents before and demonstrated heterotic increment when crosses are made from different pools. But then going forward, we realize that we need to accumulate favorable alleles in each of the gene pools and later on be able to exploit more the heterosis much better at later stages. So in part of our breeding, we usually make intragene pool crosses. That's where we're selecting parents. But then when it comes to product development, we now use the intergene pool crosses. That way we keep getting better gain from it. Thank you.
Thank you. Wolfgang, please unmute yourself and you can ask the question, please.
It's not a question. It is only a comment which can also help to explain the results in Mozambique, where parents and farmer varieties in Mozambique, and then there were this high iron population between. So if the local material and the parents used there are completely different. That this high iron population is coming from Peru. It is on basis of the PJ, as jewel population, and the Zapallo population. Also, the parents are here. It turns always up as under Mozambique, because we have shipped this entire population germinated in vitro to Mozambique. So they have exactly the identical clones of this population from these elite crosses as we have here. And the samples for the genotyping, they were made in Mozambique and shipped from there. But the population is from Peru. This explains a little bit this result. This looks strange, that land races and parents in Mozambique are completely different, and then the high iron population turns up between. This is the reason behind this might be that the high iron population, these elite crosses, are actually from Peru and based on the Zapallo and Jewel population, from which we made the hybrid population for high iron things. So
Thank you. Thank you for the clarification. Thank you very much. Dongyan, you can unmute yourself and you can ask the questions.
Thank you. So, hi, thank you, Ruben, for the nice presentation. So I'm the genomics lead from Breeding Insight, and I am the lead in developing the sweet potato DARTech panel. And so we are currently, as you said, like we're working with a large consortium, like try to update the current sweet potato DARTech panel by removing some monomorphic markers, and also those like amplified like with like tons of rays that are lots from like a paralogous amplification. So with that effort, we are asking for people who are using this panel to share with us the MADC file, which contains the microhaplotypes that will help us further define which alleles that are really useless that should be removed. I know that you have shared with us the SAPE, the NECRI genotyping result. I'm wondering the one that from Peru, Uganda, and Mozambique, whether we have that data or not. If we have that, that would be really helpful. And we are building microhaplotype database for sweet potato for this panel. So currently we are at like a 35K microhaplotypes for this 3K marker loci. So if you can share with the other data, like it will be really helpful for us to build the microhaplotype database and also further refine the panel to for the next version. We are exploring some analysis actually on the microhaplotype level. So I think that will be useful for lots of like a polyploid breeders. Yeah.
Thank you, Donia. Ruben, I'm not sure if you want to comment.
Yeah, thank you. I think from the last meeting we met, we agreed to share the files. I just need to follow up and find out if they were shared. Moktas could come in.
Wonderful. Thank you very much.
Moktas,
yeah, just a quick comment to Dongyan. Actually, yes, we promised to share all the MIDC files. We were just looking for them, but I think now we have everything available, and shortly we will be sharing it to you and your team.
Perfect. Thank you.
Anybody have any other question? Because I have a comment, and Cesar, please, before I make the comment and the question, please unmute yourself.
Yeah. Hi, Anna. Hi, everyone. I have just two questions, quick questions, and very different areas. If you can go back to the dendrogram, the circle, the previous one, please.
Big one.
Yeah, the big one.
Yes.
Yeah, that one. Do you have any explanation about why some of the samples are mixed there? For example, you mentioned that in the Uganda group, you have some Mozambique samples. Do you have any explanation about that? Why?
Yes, we are, as platforms, we are constantly exchanging materials.
Okay,
So yeah.
That is quite normal. Shared germ plants, but you know, I was thinking about some replications. Maybe you have the same material. And the other one is about capacity development. The last sentence in the last slide. You mentioned that it could be good if, yeah, we have some capacity building activities there or procedures there. How do you think that the CG system, SIP, or the whole system, CG system, could help NARS partners in terms of the cap depth or capacity development? How do you think that the CGIAR system can help you or help the NARS partners in this area specifically?
Yeah, we think planning some of these projects together is one way where a study can be done concurrently, and that's one way we see it. But then the other way is there are a number of current efforts like going on that will later on make it much more user-friendly for everyone using the system. So if our partners can be supported with leaf sampling, just training in leaf sampling, requesting for analysis and being able to interpret the data, I think those are some of the areas that it's that capacity, somebody knowing how can this tool help me better select better parents for my population, for my breeding program, or help me be able to do the QA/QC for my material. So it's highlighting the importance, but then also highlighting how practical it is for a breeder to utilize these tools.
Absolutely, I agree with you. Thank you so much.
Juanjo, you can unmute yourself.
So I just wanted to add a little bit these are to do simple things, sampling techniques, drying techniques, how to interpret the results, and how to use the information among the breeding programs to make sure that they accelerate their breeding and also they achieve the genetic gains in their programs. Thank you.
Ruben, Godwill, one of you can answer.
Thank you for the opportunity and the nice presentations. Ruben, this is calling from Ghana. You know me already.
Yes, I do know you.
throughout the presentations, I could see that East, Central, and Southern Africa has been taken care of in all these developments. But your partners in West Africa have been left out. I'm not too sure if this is the right platform to find out from you. Is West Africa now out of the sweet potato community of practice?
Certainly not. We are currently, like God will explain, we're currently transitioning into a CGIAR network. Now, as a CGIAR network, we have different characterization of partner members, and eventually with that characterization also comes different needs for different partner members. So, and then also different roles. So West Africa is there in different ways, but I think some of the activities have not started to include the tier in which the characterization, the classification in which some of the countries like Ghana have been characterized. But I think a country like Nigeria has started exchanging materials with us also. So it's a process, a transition process that we're going through on how to work with each other. I hope that
okay,
clarifies.
that's fine. Thank you.
And Eduardo, you can also make a follow-up with the, is it Mariam from Ghana? I think she participated in one of the CGIAR NAS network meetings. She's making contributions, and she also raised the concern which you raised. And I think they are now starting to make some partnerships.
Okay.
If that is, yeah, you are Ghana. Yeah.
All right. Thank you so
Yeah.
much.
Yeah.
Any other question? Otherwise, I have a very general question. Can be for David, Ruben, or Godwill. So, and correct me if I'm wrong. So generally, the potato breeding has been more advanced and with more extensive research than the sweet potato breeding. So what the sweet potato breeding can learn from the potato?
I'll attempt to answer that from my perspective, but maybe I think you guys are already underway, going a good way towards working together as a one large community. I think especially in North America, the potato breeding community works together very well on the marker development aspects of that, and sort of like our DART tag was built off of the work that was done through a USDA SOLCAP project, a SNP array. So there have been some kind of building on previous resources. I think there's some commonality that the sweet potato could take advantage of in the potato world, like the software. I think there's some good through the polyploid tools group, which I think some sweet potato members are part of.
Thank you. Ruben, Godwill, do you want to add something?
Yes, for one of the strategic directions we've taken as SIP is we're operating as more or less the same breeding team, potato and sweet potato. And so far from the interaction, we're already learning a lot from across the whole range, right from the seed systems to the marker-assisted breeding and all this genomics work. Even the computation, the analytics of this work, we kept working together with the sweet potato team in all the way. So there is a lot of cross-learning when you work together as a team. So where we have some advancements, we're glad to share, but then also where most especially for potato in Africa, we're glad to they're learning many things from the sweet potato group, but then also us, we're learning a lot from the team in the potato breeding team in both Lima and the US with Craig's team.
Thank you. Thank you very much. I don't see any hand raised or any question. So I just want to finalize with a comment. So I'm very happy to see here in this slide that a smaller set of dark tag markers like 150 would be useful for routine use, because in soybean that was also found around that number of markers. It was not used, the dark tag markers, but it is very interesting to see also in sweet potato the same. So if nobody else have any question, Mokhtar? Yes, please.
Yes, Anna, I will catch up exactly on the comment you just made right now. And remember last year, and I think Ruben and oh my God. Yeah, Ruben and Godwill actually showed it already. We found last year that we need about 100 to 150 markers for a correct use for quality control, because you know the cast markers can work very well if we're dealing with straight markers, because sometimes we don't need in so much detail. I mean, every time it's good, mainly if you are selecting for parents to have the dosage, but actually for selection in early stages, sometimes you don't need maybe to go in those details, or maybe the data you would have in diploid level can be useful. But for the QC, we need to do the dosage calling, and that is the main issue we have with the consistency sometimes of cast markers. And actually, if we think about a large set of markers, and then we need to compare individuals with that data. So all that long story is saying, or asking you actually, what can the EIB propose, for example, for polyploid crops towards that? Because I think creating a new marker panel specifically for QC implicates some costs. I'm not sure if actually EIB is considering to support the polyploid teams to develop and validate those marker panel, and also finding a way for a cheap routine use of those markers.
Thank you, Mokhtar. Yeah, it's very interesting, your question. I cannot give a proper answer because I'm just one member of the team, but definitely if you reach to Eng, to myself and Rajaguru and now Nana, I think we can discuss that. And I'm sure that if it's good for the team, it will be good for all the partners, including for ourselves. So it's something that we can explore. This is what I can say now, Mokhtar. So
Perfect.
just write to us.
Thank you. Yep. Thank you.
So if there is no more questions, we finalize the seminar here. I say thank you very much. Very grateful, David, Ruben, Godwill, all the team, all the participants. And thank you for your time here. And we hope to see you in our next seminar focused on maize in Argentina, South America. And it will be presented by Maria Laura Federico from CONICET INTA. That will be introduced by Dr. Rodomiro Ortiz from SLU Sweden. So thank you very much to all and hope to see you next time. Thank you.
Thank you.